Hi, everyone. Welcome to our conversation with Ari Juels and some of the great work we'll be doing together. I'd like to once again welcome Ari as our Chief Scientist and to say thank you to him for working with us for these many years and for taking his immense intellect and experience and focusing it now on the set of problems that we're working on. We're all very grateful to him, and it's been great working with him so far. And I think his ownership and thoughtfulness being put into Chainlink even more is gonna really take us to the next level. So I'm excited to chat with him here and the rest of the community and with the rest of the community about some of our plans and the things we're building. And I think it's going to be very exciting. So Ari, thank you again for working with us. And the kind of the first initial question, I think, is what is the nature of the problem we're working on? Why is that an exciting and worthwhile problem to be working on in your opinion?
Well, I think the best problems in computer science are the ones that are easy to explain, but hard to solve, with rich layers of complexity as you dig into them. Consensus, of course, is the best known example in the blockchain community. At first, you think, how hard can it be to get a bunch of servers to agree on a message or a sequence of messages? It seems pretty simple on the face of it. But it's exercised the minds of top computer scientists for decades now. And then, of course, in 2008, Satoshi Nakamoto dropped this completely new approach on the heads of scientists. Right? The Oracle problem, in my view, is similar. Right? How hard can it be to relay a correct piece of data from a few servers to a smart contract? Now, can't you just bang out a parser in 10 minutes? But it turns out that truth in computing systems is almost as challenging as in real life. What if the web servers disagree? What if the Oracle nodes disagree? What if there is an adversary present? There's some overlap here, in fact, with the problem of consensus. And then there are a whole bunch of other challenges, of course, like what if we want confidentiality? How about the ability to connect with legacy systems? Is high performance possible? As you know, my former PhD student, Fan Zhang, who's now going to be spending the year at Chainlink productizing DECO, I'm happy to say, basically wrote an entire excellent thesis on this very question. As for Oracle's importance, when I first came across Ethereum several years ago, it was clear to me that smart contracts, in order to do anything interesting, would need access to external data. With price feeds, DeFi has taken off. So just imagine what will be next as we have a richer data ecosystem and as smart contracts can draw on the full power of the internet. And this vision is the reason that you and I and Steve connected back in 2016, 2017. I think you had a similar view, and I think our views have continued to evolve a bit, but in the main, the story remains the same.
Yeah, I completely agree. I think I really see it as an evolution in that people have started to create systems that prove things at a much higher standard in the format of a blockchain. And those initial incarnations in Bitcoin and Ethereum were very important as far as getting all kinds of value and initial use cases working. But then I think the place that we really came together, even in our initial conversations, was the importance of how these systems interact with various data that you would then write a contract about. So I remember that was a very clear thought that both you and I shared initially. And I think it's a very logical thought of, yes, these systems are very important for storing contract state or storing certain transactions or maybe retaining certain private key signing records and creating a globally shared record. And I've always agreed with that. And that's a very good starting point for how this technology kind of comes into existence and begins a foundation into which you would put certain data. But the question then does become, how do you expand beyond that, right? How does the space evolve into something that works for the financial system, that works for global trade, that works for the insurance industries of the world, which are all really fundamental industries to how our daily lives are able to be the way that they are. It's just, I don't think it's super clear to most people how dependent they are on all these contractual systems. I think it'll become more clear to them over time, especially if some of them don't work the way they're supposed to. But it's definitely a worth problem in that sense. And I think that there's definitely going to be serious demand for the type of definitive truth that we're seeking to create and the type of assurances that blockchains and oracles together combined can provide, right? I think that's a whole new level of assurance about the state of the world, about the state of the relationship that people have to data, to assets, to systems that inherently have very strong impact on their lives. And once again, I'm really thrilled that we're working together on it. So thank you once again.
Likewise.
I guess the second question then would be what led you to become, our chief scientist and to take a leading role in our research program into how and around how Chainlink will evolve? What led you to come to working with us on all of this?
Well, I really enjoyed my time working with Chainlink over the past few years, and particularly appreciate the seriousness with which Chainlink takes academic research and the fact that Chainlink strikes what I think is a good balance between meeting the urgent needs of customers and investing in the critical but all too easy to put off until tomorrow need for innovation. For me, leading the research program along with Lorenz Breidenbach is an unprecedented opportunity, really, to bring research ideas and principles that I've been exploring in academia into the real world. So thank you for that opportunity, Sergey.
Yeah, absolutely. It's our great pleasure. I think from our point of view, I think I've said it 3 times now, but we are just grateful to be working with somebody of your caliber, and there's only a few people in the world that I think can really reason through these things the way that I've seen you and the people that we work with on the research team really think through this in a detailed way. I think the other thing that really excites me about the research program is that Chainlink has always really been based on research, on some foundational ideas that came out of the computer science world, and a lot of that was influenced by your thoughts on all of these points and how all of these, standing on the shoulders of giants ideas can now be composed and then expanded on, improved, right? And as I look at the way that people build foundational infrastructure in our space, I really think that's the right approach. I think the approach that I see sometimes where people either try to make a web service and say, oh, it's fine, don't worry about it, I'm just going to make a web service from some web architecture that I know and call it highly secure, cryptographically kind of proven system, right? And that's what I'm going to do. Or sometimes I see people copy things like blockchains and just try to turn them into something else, right? I think a principled kind of foundational approach to what is the problem we're solving and a rigorous system for reasoning through that problem while standing on the shoulders of giants and combining their work with new additions we can make is really what every kind of real technology company should seek to do, in my opinion. And so I think the research program is going to really be a combination of these things we've already been doing and just a great expansion of it and kind of a scaling up of implementing the best possible approaches to enable secure data transmission, data validation, various proof about data at this new extremely high standard of definitive truth and kind of the standard that I think the world is going to need, basically, for relying on data and relying on systems, and that standard is thankfully now, due to a lot of the work you've done and other great people like you, can now be made to hit a much higher level than before, which I think is coming exactly at a time when people need reliability and need assurance that the systems they're using actually provide them what they promise to provide them. And that's a very, I think, so it's a very exciting, important thing to research and work through, and I'm thrilled to be working on it with you. So Ari, in the context of the research program that we're working on together, what are the some of the bigger problems that we're working on and working through at the moment and in the future? I know we can't cover all of them because there's a lot of different ones we're working on, but let's maybe just cover a few and then focus on some of the more immediate ones related to some of the topics we've announced here at the conference.
Yeah, we're certainly working on a variety of research challenges, but let me mention maybe the top 2 or 3. The first, of course, is scaling. The question of how we get high throughput for Oracle queries and reports, and also how we achieve low gas costs. The community is working on layer 2 scaling solutions for blockchains, and there are quite a number of them, a diverse array. One of our challenges is to figure out how we're going to draw on and interoperate with exactly these advances. A second big challenge is this notion of staking, or cryptoeconomic securities, people like to call it. I kind of prefer the academic term, mechanism design. This is another problem, like the consensus problem, like the Oracle problem, that seems straightforward on the face of it. It seems as though you could just have nodes make a deposit and slash them when they provide faulty reports. But it turns out to be much more complicated than that. Now, previous works in this area, for instance, haven't modeled adversaries strong enough for our purposes. They haven't modeled, for instance, the full range of possible bribery attacks. So we're working with experts in mechanism design to ensure that our staking solution, once we roll it out, will be carefully and thoughtfully designed and robust. Another problem that is really critical, and one, of course, I'll be talking about later today, is the problem of confidentiality. People are today, I think, so sort of mesmerized with DeFi that they're willing to overlook its lack of confidentiality in some critical regards. Addresses, trades, all kinds of things are exposed on chain. And I think users are going to come to demand stronger confidentiality. For enterprises, it's an absolute requirement. Oracle systems need to be part of the solution because oracles, of course, are handling sensitive data, both queries and reports. So those, I think, are the top 3 research challenges we're working on and will continue to work on.
Yeah, I agree. I think scalability is something that we're going to have to solve more and more, because even if we solve scalability for putting data into layer 1 systems, we already have many layer 2s that want Chainlink data inside of them as certain applications migrate to them. And then you start to see also a number of mission critical systems from the web world and the existing enterprise infrastructure that have extreme speeds already, right? Because that stack is very well developed and they have a whole different set of assumptions about speed and responsiveness. We are seeing a number of use cases for Chainlink validated data beyond even layer 1 and layer 2 blockchains and into mission critical web system processes, right? Whether that's at technology companies or enterprises. And so I think that the scaling of Chainlink it's progressing very well now, and it's progressing to meet the demands of our most immediate users, which are the DeFi users on layer 1, soon DeFi and various others on users on layer 2, and then relatively soon also certain tech companies and other web grade systems that also need validated data. So scalability is going to be an ongoing thing that we need to continue to improve upon, because the amounts of data that we're going to want to validate and kind of pass through into a state of definitive truth, into a state of being reliable, is going to continually increase as the demand for validated data increases. So I completely agree that that's a highly needed continued set of improvements that I'm very glad we're doing incrementally to meet the demands of our users. Cryptoeconomic security and staking, I think you're right that it is a very nuanced problem, and that it also needs to scale with the value secured. So I think there are versions of staking that can work for certain sizes, right? And it's something that we need to roll out in a way where not only do we provide the technical foundations of staking, which I think are very well along and clear in how some of those things will work, I think we also need to provide certain amounts of guidance. And that guidance then needs to evolve against market dynamics for how stake will be put up against certain scenarios. And just like oracles vary in the types of reports they give and the types of contracts they work with, the various staking guarantees that they provide will also need to vary according to different use cases. And so what you're trying to make is, in my experience, a framework that can provide these guarantees for a number of use cases, can also scale to meet the security demands of those use cases as the value they secure scales, and can do that in a way that's immune to all kinds of adversarial kind of behaviors. So it is something that I think we'll be making work initially in a straightforward way, and then it'll continue to advance and evolve together with the help of our community and various users that help us even help us define what are the proper requirements that people should seek to give in regards to stake and deposits and the mechanisms and the mechanism design that they're relying on, right? Because a part of it is also the user's comfort level and all those types of things. In terms of confidentiality of data and compatibility with existing systems, I think that's absolutely right. I think another place where you and me really do come together very, very clearly on all of our thinking and have for many years now is the need for privacy preserving systems that enable the usage of various valuable data and the interaction between enterprise systems and blockchains. And I think that really has these two components of you need some kind of technology that creates confidentiality or a set of technologies, and then you need a system like Chainlink that's integrated into all these enterprise systems and integrated into all the data sources to make that technology usable. And that's I think, a very challenging high standard to meet, but I think it's very worthwhile because once you create privacy, I think you generate a lot of new data, premium data that can go to DeFi contracts. You can make all kinds of user credential data accessible without really revealing it to blockchains, but you can still have it useful on blockchains. And then enterprises are just generally very privacy conscious. Like all the enterprise implementations I see, their first selling point is privacy. We provide you privacy, right? And so if you can make existing enterprise systems compatible with blockchains while allowing them to maintain their privacy, but still prove that the different data that they have in their systems or the different data they rely on from data sources is a certain way, you give them the benefits of blockchains while allowing them to use their existing systems, which is exactly what all of them want to do for the trillions of dollars they have secured on those systems. I think this might be a good segue to consider how you see DECO playing into this, and to briefly give us an overview of how DECO could fit into this goal of both confidentiality and compatibility with things like enterprise systems.
Well, the way I view DECO, fundamentally what it does is extend the reach of Oracle systems safely into private web data. This is important for enterprises. It's also important for users. I'll be giving a couple of examples later today, but it's worth perhaps mentioning those briefly now. One would be decentralized identity, this ability of users to create and manage their own credentials. These credentials that users are going to create are going to rely on privacy-sensitive data. For example, if you want to prove that you are of age to sign a legally binding contract, you want to prove you're over 18, you're going to have to draw on an authoritative record of your birth date, and that's clearly something you don't want to reveal on a blockchain. A confidentiality-preserving Oracle system can translate a birth date into an attestation saying you are of age to sign a contract without revealing your birth date to Oracle nodes, without revealing it, of course, on-chain. And I think in general can be very helpful for bootstrapping decentralized identity or the decentralized identity ecosystem. So that's one really important example. Then a whole slew of examples revolving around connection of enterprises with privacy-sensitive data to smart contracts in finance, in trade. Talk about a supply chain example later today. Premium data to which users connect using an access-controlled system, using API keys, for instance, can be leveraged in an Oracle system only if confidentiality can be provided for the API keys and possibly even for the premium data. It may be possible only to publish digests of premium data on chain, given the contractual obligations that node operators have with the sources of data. So these are a couple of settings in which I see confidentiality as critical for enabling enterprise systems and users to rely on blockchains for myriad needs that are unmet today.
Yeah, I completely agree. I think it's quite exciting when you have new categories of data being made available to the internet, or in this case, to blockchains. I think historically what we've seen is that once you create a certain either security or privacy around certain types of data, it makes its way into applications. And people can then use it to build all kinds of things. The kind of canonical example I always have in my mind is, before HTTPS, I don't think people would have really had e-commerce. I don't think you would have really been sending around credit card numbers. People wouldn't have been inputting their personal credit card numbers that if somebody compromised the data, they would be able to just steal money from them. And then once you did have encrypted connections for data, once you were able to maintain a certain degree of privacy, you did have a huge kind of explosion in the applications that could then use credit card data. And I don't even know if people foresaw that. I don't know if people foresaw that, HTTPS means credit card data means e-commerce, right? And I think this is a similar type of dynamic for initially for blockchains, because blockchains, I think the thing that people don't understand when it comes to blockchains and data transmission is that blockchains inherently seek to make this single source of truth transparent. And therefore the transparency seeks to create a public nature to the data, right? It seeks to create an auditable, public, transparent record. And that actually extends even beyond public blockchains and into these semi-private consortium kind of blockchains used by enterprises. They still have the same problem where they essentially want to create a record, a shared record among all the parties, but the transparency that creates sometimes is worrying to certain members, right? But they still have data, or they still have some relationship they want to have to that record. So now I think with DECO, the fact that you can take entirely previously inaccessible categories of data, whether that's premium market data, whether it's data from enterprise systems, whether it's personally identifiable data for AML KYC around the use of something like DeFi, right, by institutions or by other entities. With this data now being made available, I really do see a lot of use cases for it, both in the public blockchain and in the semi-private kind of consortium chain environments. I really think that people don't always appreciate the connection between how when data appears in a system, suddenly you can do things that you couldn't do before. And I think this is what really the evolution of DeFi is a testament to. And I think the ability to put high-end market data, enterprise data, personally identifiable data, not on-chain, but into systems that can then prove on-chain that the data is a certain way, so that you maintain the privacy of the data, but you also gain the use of it in these blockchains. You really do arrive at a much larger landscape of things that people could do. And I think that's really both the goal that you and I have always had, and the goal that Chainlink Labs has, and the goal that we all really have is, how do we take this unique method of defining truth about state or about data or about the world, and how do we combine it into something that is unalterable, tamper-proof, and truly reliable for a global system of contracts. Ari, thank you once again for working with us in all this. I think it's a truly worthwhile goal that we're embarking on fully solving here. And I'm excited we're doing it together with you and all the other great people on the research team. Thank you very much.
Thank you, Sergey. It's been a real pleasure working with the Chainlink team for the past few years on the first generation of the system. And I'm looking forward to the chance to work more closely with you and the rest of the team to thinking through the next generation.